Okay. So, in the previous class, we had started uh, discussions around doing calculations. Okay. So, one that is one of the use cases of any programming language, that you build different sorts of calculators, different sorts of formulas. If you have, if you would want to do calculations with them, so this is one of the use cases that every programming language has, right? So in a similar way, let's say if you wanted to do another calculation, where let's say you want to calculate the BMI of a person. Okay. So let's say, just a second now. So let's say you you know you everyone knows about BMI, right? It is called body mass index. Okay. The full form is body mass index. Basically, everyone's weight, if you just look at some person's weight, it is not exactly representative of if a weight, if the person is fit or not. So we one of the ways we calculate someone's fitness score is by calculating the BMI. So the formula for BMI is basically the weight of the person upon height square. Okay. And the weight has to be in kilograms in this formula, and the height has to be in meters. Okay. So you will square the height, and weight will be divided by that. Okay. So that is the formula for calculating someone's BMI. Okay. But if someone gives you the weight of a person, let's say it is 72 kg and the height is 1.92 meters. So these two values are given to you. We cannot assume that every person knows what to do with the weight and what to do with the height, and how to calculate their BMI, right? So if with the knowledge that we have, if I tell you that build a BMI calculator with the current knowledge that you have, I think what you will end up doing is you'll basically tell everyone that the BMI is equal to weight upon height square. So just go in your Python interpreter and just do basically this 72 divided by 1.92 raised to the power of 2. Okay. So just do this and you will get your BMI, right? And basically this is their BMI. But this is not common knowledge. This is not how you will let people know how to calculate their BMI. Okay. You cannot go to every person and tell them verbally how to calculate BMI if they don't know how to calculate their BMI. And then on top of that, you cannot be very sure that if they are providing the weight in kilograms or height. So there are a lot of these problems basically. And yesterday also we were working with a formula where we were calculating the returns after 7 years. And if you look at this formula from yesterday to today, probably you won't remember. You will have to apply your brain again and think, okay, 100 was the amount, savings amount, 1.1 was the multiplier, 7 was the number of years. You will have to go through it again, and then you will come to know. Okay. Think about it hard, and then you'll come to know. So basically we are facing one problem, that we cannot tell the formula of doing a particular calculation to everyone. And how do we basically tell people who want to use any programming language to provide a certain type of value where it is required, and do the calculation that they want to do using the formula that we provide them, right? So how do we solve that problem? Okay. The problem, everyone understands what is the problem here, right? basically as the developer, you know what 72 means, you know what 1.92 means, but you cannot expect everyone who is coming here and reading this to know that, okay, that this is weight and this is height. Okay, so how do you do that? You use something called variables. Okay, variables. So what are variables? Variables are basically the name that you give to your value. Okay, so you have a value. So in this formula above, 72 is a value. Okay, and the name for it in general, like common terms, you are calling it weight. So we can basically, what we call something commonly, we can take it into programming language and call it with the same name pretty much in the programming language also. And what happens is, instead of using the value again and again, you can just use the name. And Python interpreter is smart enough to basically relate the name with the value and use the value in the calculation whenever it is required. Okay, so what I can do here is I can say weight is equal to 72. Now you might be thinking, coming from a math perspective, that I am putting two things equal to each other. Okay, so the last time we did something similar was in mathematics, right? We used to say something like x equal to y, right? So x equal to y, what did it mean basically whenever we said x equal to y in mathematics? Can anyone?
Variable.
No, it did not mean variable in mathematics.
Is equal.
We can either use x or y in these calculations.
Yeah, basically when we say x equal to y, this whole thing in totality means that I am trying to check, or I am testing equality. Okay, I want to check if x is equal to y or not. Okay, either we are telling somebody that x is equal to y. Let's say we are writing this in an exam paper, then we are telling the examiners that we were these steps I did and I was able to verify that x is equal to y. So either we are telling that these two values are equal, or someone is telling us that these two values are equal. So it is a way of communicating that, okay, that these two values have been tested to be equal, or we are informing them to go ahead and test the equality for us, go ahead and check if x is equal to y or not, right? So here equal to is to test equality. Okay, but here in the terms in the programming language, when we say that weight is equal to 72, what happens is we are not testing equality here. With this, we are assigning the value of 72 to the variable name. This is what we call variable name weight. Okay, to the variable name weight we have assigned the value 72. So this is the process of assigning. Okay, in the programming language, if you want to test equality, if you want to do something similar in the programming language, then you are not going to do this. You are going to say something like x equal to y. So this is to test equality. Okay, so you are asking, or you are telling that these two values are equal, 2 times equal to without any space. Okay, so this is another symbol on its own. But here if you just use one single equal to sign, it means assigning. It is not to test equality. Is it clear? Any doubts? So when I do this, when I say weight is equal to 72, I have assigned the value of 72 to the variable weight. Okay, in a similar way, and you might be noticing I am writing something with hash, and I'm generally I'm leaving a space after it, but anything if we put under after hash, it gets converted into a comment. Okay, so anything if you write after the hash in a particular line, it is considered a comment, and the Python interpreter does not run that line. Is it clear? So we can use these comments further, and we can mention in the same line something like in kilograms. Okay, so this is to inform somebody that you have to provide this value in kilograms. Okay, then similarly I can say height is equal to 1.92, let's say in our case, and then just to inform somebody we can mention in meters. Okay, so this is the weight and height of a person. So to calculate BMI, what we can do is we can say weight upon height square. Okay, so here I did not leave a space, let's leave a space, and can do that also further. So if I run this code, it will calculate the BMI for me, but this is still not complete actually. Okay, there is one more thing you should be doing, and that is you should be putting BMI equal to this, and then when you write this same code in a Python script, okay, so again what will happen if I just put this much, this the user will not be able to run it. Let me show you. So if I take this and go to my Python script that I had, if I just do this and try to run this, even though I ran the script, nothing happened. Okay, so what should we be doing? We should be printing it. Okay, yeah, right. If I add this line also here, and now save it and run it, you see it prints in the terminal. Clear? So what have we done? We have done assignment. The value got assigned to a variable. Now if I hand over this piece of code to you and tell you that just go ahead and calculate your own BMI, now is it more clearer to calculate BMI, or was it more clearer or more understandable how you will calculate BMI in this case? Obviously in this one, right? Second one, right? So because everything is clearly mentioned that okay, the variable weight will obviously in real world also it means weight. So that is another important lesson. Although we are learning about variables, I could have used just W as the variable name. I could have just used H for height, okay, and still it will work. I'll use W here, H here, and I'll calculate BMI. But the more descriptive variable names you use, the better it is. Okay, just put in that extra effort, go ahead and type that whole word, not a big deal, because any which ways, even if you create a script in 2 days, that script is going to stay with you for years to come. Okay, so just invest that time in writing that script. Don't be lazy about variable names and all, because if you end up writing a long script with variable names like A, B, C, D, X, Y, Z, after a while, let's say your script length is going somewhere 100 lines, 150, 200 lines, you will have no idea why X, what you're doing with X, what you're doing with Y, and what is W and what is H. Okay, how many times you've used it over and over. So just invest that time. Once you've created a variable name, all these modern IDEs, VS Code and all, if you just type weight, it will give you as a suggestion. Okay, most of the times tab completion is available. So just invest that time in creating proper variable names. It will help you only. At least in the initial times, it will be even more helpful to understand what exactly you are writing. Okay, fine. So Now if I just give it to any person can put in their values and calculate their PMI. And this is also something we called reproducibility. Okay, the concept of reproducibility, everyone can now reproduce results again and again with the same piece of code. Okay, so you have basically created what? You have created one kind of, you can say, a black box. Okay, you give it two inputs, you give it the value of weight, you give it the value of height, and this box basically gives you the value of BMI. Okay, so you have created this box basically. Okay, you are giving it some inputs, you are getting some output. Okay, so moving on, till now if you look closely, what happened here is that we if I show you from yesterday's class also, or from the Python script that we wrote, you might have noticed that we have we have written a lot of code, and you might be seeing these different color codings with different types of objects or different types of data, right? For numbers you are seeing that it is using that green color, and for text it is coming in as orange color, and you are seeing numbers, you are seeing text, you are seeing all these different things here. So and how is basically Visual Studio Code understanding that okay, since this is a number, let's color it in green, or if this is a piece of text, if if it is a string, then it should be colored in orange color. So basically there is some understanding there, right, that it is identifying different types of data differently, and basically since VS Code is understanding it differently, obviously the interpreter also in the background might be taking these values differently, right? And probably it might even have different rules for working with these different types of values, right? So the next topic we are going to talk about is object types, or also sometimes called data types. So when it comes to objects, okay, or types of data in the case of Python, at a very high level there are two types of data. Okay, one is the fundamental types, the most fundamental types, you cannot break them further, there is nothing inside them, they itself exist as an entity. And then you have the complex data types or object types. Okay, in this course of Python I will keep using the word object, because in Python everything is an object. Okay, any piece, any script that I have written, that is also an object. Any variables that I have created, that is also an object. Any data value that I assign to some variable, that is also an object. Everything is an object, because Python is a object oriented programming language. Okay, so don't get confused, everything is an object, and as we go through the course you will understand this more and more, and how the objects are defined and all these things we'll discuss later on. So at a high level, coming back to our discussion, we have two types of objects or two types of data, fundamental and complex. Okay, so fundamental cannot be broken down further. So when we discuss fundamental, there are four fundamental types of data or four fundamental object types. Okay, the first one we are going to discuss this one we'll leave for later. Okay, the next type of objects that are going to come further in the class, those I'll tell you what complex means. Okay, so the first type that we are going to talk about is integer. Okay, so integer, the short notation for integer is int. Okay, so what are integers? Integers are whole numbers. Okay, You all know them from mathematics. Whole numbers with no decimal part. So examples, all these numbers 1, 2, 3, 999, 1000, 1001, whatever. All these numbers are examples of whole numbers. They don't have a decimal part in them. Okay, any number that you can think of which does not have a decimal is a example of integer. Okay, then the second one is float. Okay, the short notation for float is also float. Okay, where these short notations come in, I'll show you later. So short notation is also float only for float. And what are these? These are fractional numbers basically. Okay, with decimal part. Okay, examples, anything 1.1, 2.4, 4.3, etc. So if in the normal mathematics, if I ask you from whatever knowledge you have from your school days, if I ask you 4.0, let's say, is this a whole number, is this an integer, or is this a float? Anyone?
Integer.
Yeah, so
Whole number.
it will be an integer. In normal mathematics, it is an integer because the decimal part is 0. Okay, but in the case of programming languages, even 4.0, and after decimal, if you are mentioning the decimal and if you are mentioning any number after that, where even if it is 0, it will be a float. Remember that. Okay, if the number has a decimal, if you mentioned the decimal or during the calculation the decimal came in, it will be considered a float. Clear? Any doubts? So anything with dot 0, okay, 118.0. So all these are examples of floats. Fine. So the next fundamental data type is string. The short notation is str. Okay, and what are these? These are text, pieces of text defined using either double quotes or single quotes. Okay, so both are allowed. You cannot mix and match. It cannot be one side you are putting double quote, one side you are putting single quote. That is not allowed, but both of them are allowed. If you create a text with double quote, something like hello, this is also a string example. And if you create something like world and you put single quotes around it, it is also a string. So now some people very easily, at this point itself I'll clear one doubt for you. There is a difference between the variable name and the strings. Remember that always. Okay, these are variables. Okay, you see, while writing this, have I put double quote or single quote around it? Have I done that? No, right? So this is a variable. Never get confused between a variable name and a string. Okay, string is an object, variable is a variable. Variable represents an object. Okay, but string with that you create with double quotes or single quotes, that is a string. Okay, so at this point itself I am telling you, don't get confused between these two things. Now another thing about strings is that even if you write one number, let's say 423, okay, and if you put quotes around it, this also will be categorized as a string only, because this is no longer a number, it becomes a string because of these quotes. Okay, these codes are important. Okay, don't take them for granted. Okay, so this also becomes a number. If I put 1.46 and I put quotes around it or double quotes around it, it is also a string and it will be treated as a string. Okay, any doubts till now? Okay,
No.
yeah. Then you have the fourth data type, fourth fundamental data type, that is Boolean. Right? The short notation is bool. Okay, this is something those of you who've done engineering might have very commonly heard about it. It is basically nothing but programmatic version of, in the real world we say something like yes or no, right? The answer is I'll not put quotes, you'll get confused. So yes or no. Okay, in the real world, to at the end of every decision making, if the two choices that we generally make is yes or no at the end of the day, right? Either we are going to do something, either we are not going to do something. The choice is almost binary. Have you heard this word binary? I think all of you must have heard, right? Binary means 0 1. Okay, so to represent that in programming, we use the words true or false. Now, as far as Python is concerned, okay, this true will always be with a capital T and all the other letters are in lower case. This does not mean Boolean true. This does not mean Boolean true. Only this means Boolean value or Boolean object type true. Okay, similarly, this is false, this is not false, this is not false. Understood? Anything other than this, true and false, with capital T, capital F, other letters small, anything else if you will write, Python interpreter will not take them as a Boolean value. Everyone understood?
Yeah. Yes.
Okay, so moving further, so here if you remember, we have created 72 is an example of what?
Integer.
Integer, right? This is 1.92 is an example of float, right? This is an example of string.
String.
Okay, so let me just create some values and even let me show you that in Python, if you want to check the type of any data or type of any object, what the interpreter in the background is understanding that object as or that data as, if you want to check it, just like the print function, we have another function called the type function. So how do we call a function? We mention the name of the function and we put the brackets and we give it input. So our BMI was calculated something like 19.53, right? So if I ask it, it is float. Okay, so similarly, if I check the type of the variable BMI, variable, as I told you, represents the original value, this value, right? So if I check that also means the same thing. If I check the actual value or if I check the variable name in its place, that means the same thing. It is going to get converted to this value, and this value will be checked. Okay, it is not going to be the variable. Variable just represents that value. Similarly, I can check the type of height, right? I can check the type of weight. It is an integer. So you see all these short notations are coming in integer. Okay, let me create some more variables. The string 1, let's say I've created one variable string 1. I'm saying something like the router is down since, let's say, 2013 hours. Okay, let me create another string. Router is up now. We run this block, so it is read by the interpreter. Now I can check what is the type of the variable string 1. It is str. So interpreter is going to understand it as a what? As a string.
String.
If I run this, string 2 also str. Clear?
But
You
in starting, if already written it's a string, then only because in above you have typed weight with brackets, but it is showing integer or float.
here
There is
also
some.
brackets are there, na?
Mhm.
This is the function name and the brackets. That is standard. That is the way you call functions. What you are providing as an input inside the brackets can vary. Okay.
It is showing string because we have double
I
quote and
Yeah, I created that string, right? One example I've created with double quotes, one I've created with single quotes. Okay,
okay.
just to
Okay,
show you.
understand. Thank you.
So moving on. So let me now show you the fourth type. So I'll create one boolean 1 true, boolean 2 false. Okay, so when I run this, now it has been read by interpreter. Now let's check the type. Boolean 1, it is being read by the interpreter as bool or boolean. Okay, similarly if you want to check for boolean 2, that is also a boolean. So these are two values that are identified as boolean values by the interpreter. Okay, now I was telling you about these different types of data, like I kept using the word, the interpreter is understanding them as a boolean, the interpreter is taking them as a string, the interpreter reads them as float or an integer. So there is something here, right, that interpreter wants to take that value also, but also wants to understand the type of the value, right? In the case of Python, we are not telling explicitly that what is the type of data. Okay, it understands just by looking at the value. But in other languages, if you'll probably go and study Java or something, you will explicitly tell it that okay, I'm creating a boolean here, I'm creating a this thing here. So those older languages you have to explicitly tell. But here, just because we are uh, writing it in a certain way, it is able to understand. That is what we call the differences in high level languages. Okay, so the other important factor is why it needs to know the type of the data is it has to also decide what action the interpreter has to take. For example, if I say 4 plus 5, it knows that since this is also an integer, this is also an integer or a number, and there is a plus operator in between, it means it has to do the operation of addition, proper mathematical addition, and that is why it gives me 9 as the result. But if I take something like am plus it, okay, these are two examples of strings and I am using the same plus operator. So this time it is giving me a string as a result. It is not trying to do addition. So what is this operation called? Can anyone tell me?
Concatenation.
Concatenation, exactly. We have this in Excel also. If someone has done this in Excel, they will know, but it is called concatenation. Okay, this is not addition. We can in the layman terms, in the day-to-day language, we call it addition, but this is not actually addition, it is concatenation. I have just put two values together to each other. Okay, I have just stick them together. I am not adding them. Adding is a different operation. Okay, so the interpreter is able to make these calls that it has to do addition or it has to do concatenation based on the fact that it understands the type of data also. It just does not read the data, it reads the type of data also. Clear? So I know most of you. So the first problem that you guys can do if your IPython shell is ready is this one. Very basic problem. You just have to create these are just helping text. This is just help text. The problem starts from here. You have to create a variable savings and assign the value 100 to it, and then you just have to print savings. Okay, simple, that's it. Okay, I'll do it now. So basically what you had to do is I'll just call it problem 1. You had to create the variable savings and put it equal to the value 100, and then you had to print savings. Okay, now I'm seeing some of you, what they have done is they have left a space here. Okay, if you run this code, it works, but this is not the correct syntax of calling a function. Don't leave that space in between. Okay, so it makes it more confusing. It might be working, but it is not how you do it. Okay, you don't put that space in between the name, the function's name and the brackets. Is it clear? Ajit, Roshan, Gagandeep?
It's
Yes.
clear. I have not written in bracket saving. That's why I have no output.
Yeah. So let me reiterate this. How do you call or how do you use a function? Then the syntax is whatever is the function name, and then you put brackets and you give your inputs here. Okay, this is the syntax. Whether it is print function, type function, or any other function that we use in future. Okay. Clear? Let's move on to the next problem. So in this one, what you have to do is, you remember we used this formula earlier, right? So I want you to, like, savings is equal to 100 we have already created in the problem 1. In the next problem you create two more variables, that is growth multiplier and result. Okay, and the growth multiplier you put it equal to 1.1, result equal to 7, and I want you result you have to calculate for the whole formula. Okay, years also you can put it equal to years variable if you want, or you can use 7 as it is, but the result you have to calculate, which will be equal to the amount of money. Okay, the final amount. So one variable is already created for all of you. Create two more and the third variable for the final result, and print out that result. So what you had to basically do is that savings is already created. You had to create two more variables. The first one is growth multiplier, which will be equal to 1.1, and years also you can put it in a variable, probably 7, and to calculate the final result you had to do savings multiplied by growth multiplier raised to the power of years, and finally you had to print the result. Right, so those of you got this answer, I think, right?
Not getting.
Not getting? Why?
Thing showing most recent call lost. File string line 4 in module. Name error. Saving is not
Did
defined.
you? Yeah, savings is not defined. Then that savings equal to 100, is it in the same file?
Yes, the same file.
So let me go and do it. Okay. Does your code look like this? It is coming, right?
Yes, it's coming. But why am I having issue?
Is it exactly same? It is not exactly same. That's the reason. Okay. You put this inside the brackets because BODMAS rule. We talked about it yesterday, right? Is it clear? Shall we proceed? Okay, let me give the next problem to others. If you want to discuss further, we can do it. Very simple problem. Third one, again, we have created all types of like two types of variable till now. Two are left. I just want you to create two more types of variables. That is, first variable name is CI. The value should be the string compound interest, and the second is the variable name is profitable, and the value is true. Just create them and print them one by one. That's it. Very simple. Fine. Okay, so I'll also get this done quickly. So what you had to do was basically just create two more variables, that is CI is equal to compound interest, the string, and profitable is equal to true. Then print both of them. Fine. That's it. Now we have been doing all these calculations and printing out the result and all, but I think this way of printing out something is not very helpful to the user, right? We want to print it out in a nicer way with a statement telling us exactly what happened and things like that, so that whoever basically reads it understands what actually happened, right? And generally if you go to your your bank accounts or anything of that sort, in your investments accounts and all these things, they write it nicely, right, in your phone apps and something, that they mention that this is the savings account and this is the amount you have saved and this is the amount, this is the interest that you earned. So they write it nicely so that you can understand what exactly that amount means. So if a printout like this comes out, people might not really be sure what is happening. So we want to give a nice printout, let's say. So what I'll do is I want to print something like I started with dollar and then I want to put the savings amount here. Then I will mention and now have dollar plus the result plus then it should be like a full stop. Then in the next line I'll mention just one word, awesome. Okay, so I want to print it like this. It should print something like I started with dollar hundreds and now have $194, awesome, something like that. I want to get a printout so that anyone who reads this can understand, right, what is exactly happening here, right? So when I run this, it gives me an error and it is telling me that can only concatenate string to string, not integer. Okay, this is a string, the first part is a string, but what is savings? What is the type of savings?
Integer.
Integer. So what am I trying to do here? Basically I'm trying to do the addition operation or concatenation operation between two different types of data, right? I'm trying to do that between two different types of data. So let me tell you one thing about Python. Python is a very strongly typed language. Strongly typed as in not like whoever was typing Python, he typed it strongly. It means that it cares a lot about the types of data. Okay, for Python it matters that what is the type of one data versus the type of other data. If you look at other programming languages, like specifically Java jumps out in my brain. So if you look at Java, it is what you call a loosely typed language, means this operation would have gotten executed in Java, but here it will not allow that to happen. It cares a lot about the types of the data. Okay, so how do we solve this problem then? How do we print a statement which has two different types of data together? So any suggestions from anyone?
convert that
Huh?
Yeah, please, sir.
convert
Uh,
that
Type
to
conversion.
string.
Type conversion, right? We have to convert the type of data. Okay, now when we talk about converting the type of data, in this case, when you look at this example, what is the more logical thing to do? Should I convert this into integer or should I convert this into string?
into string.
Yeah, that is the more logical thing to do, right? What is the, because there will be no integer value for this long string, right? Obviously it is going to give an error. So let's do that conversion. So how do we do a conversion? Now we talked about these four fundamental types of data, right? So almost all types of data have a function associated with them also, so that other types of data can be converted to that type of data. So what we'll do, we'll take savings, okay, and we will give it as an input to the string function. Okay, so savings is now going to be an input to a string function. So you might have, like earlier we were seeing that string is a type of data. Now I'm telling you string is also a function, so don't get confused. As I was telling you, all these different types of data that we talked about, boolean or string or integer, float, they also have their own functions associated with them, so that any other type of data that can logically be converted into that type will we can convert that basically. Okay, so similarly we are going to get an error here also because result is a float. So let's convert that also into a string, and now when I print it, it prints it out like this. So this makes it more understandable, more readable. Clear? So what I'll do now is, let me show you 4 examples. Okay, you just tell me in the chat, one-to-one chat, that which ones are valid. Basically if you write them in code, they will work, and which ones will not work. You have 4 options, A, B, C, D. Just tell me which ones will work. Okay, okay, so let's discuss. So first option, most of you were right, it will work. Okay, because wherever we have numbers, integers or whatever, we have already done the conversion, and basically others are strings. I have converted one other thing that is not a string into a string, so it should all get concatenated and it will work. Okay, the second one, most of you said will not work. Okay, some of them understood, but most of you said it will not work. So let me show it to you. And the statement that I made earlier, I clearly told you that 2 different types of data don't interact, or you cannot run mathematical or any other kind of operation between 2 different types of data without doing type conversion. But here, if you notice, I am doing an interaction between 2 different types of data. One is a string and the other one is a integer, right? So let me tell you that this is one place where this rule is broken. Okay, this is one what you call that
Exception.
exception, right? So this is one exception to that rule. Okay, so, and why this exception is there? Because it is the only logical way. Otherwise, if you had to print a string hundreds of times, what other code will you write for that? Okay, so to allow that thing to happen, they allowed for this exception. Other than that, generally any other 2 different types of data they cannot interact without type conversion. Okay, So even in this case, if I probably make it something like a float, it will give me an error. Okay, so only this string and a integer. Okay, only that interaction is allowed. Okay, because it is commonsensical, it is logical. Okay, now this one will not work. C will not work, because here if you got this right, then you should obviously understand what is the problem here. I haven't done the type conversion for 2, that's why this interaction will not happen. Now most of you were dicey about the fourth one, true plus false. So true plus false basically will work. Okay, and it gives you the result 1, and the reason for that is, in the background these the interpreter, when tries to do a mathematical operation on two boolean values, it converts them into their binary value automatically. So true gets converted to 1 and false gets converted to 0. So 1 plus 0 is 1, and that is what you get as the result. Clear?
Yes.
Any doubts before we proceed to the next topic about variables, variable types, anything?
That exception we have for the string value.
Yeah.
So it's applicable for the multiplication operator or any other operator also.
Just this one thing. Okay, pretty much. I'll have to do a research. I don't think anything other is allowed without conversion. Just this particular thing with these types only, string and integer with multiplication.
Okay.
Just this thing is allowed. Yeah. Okay, so let's move on to the next topic. Okay, so if you remember, just a while ago we calculated the BMI, right? Here also I calculated in the script, right? So in the BMI calculation, let me just comment these. In the BMI calculation, I am calculating the BMI of one person at a time, right? And let's say I was given a task. I've been given a dump of data of, let's say, a family where there are 4 members in the family. So they obviously 4 members have different weights, different heights. So in one go I have to calculate the BMI for all of them. Okay, so with the knowledge that I have till now, okay, with the knowledge that I have now, what should I do? Okay, if I don't know any other concept in Python, whatever I know, whatever I've studied till now, what should I do to calculate the BMI of all people, 4 people?
4 different variables.
4 different variables, right? So probably what I'll do is I'll create one variable height 1, then can you mute? So I'll create 4 variables, and second I'll probably name it height 2, third one I'll name it height 3, or probably I can put the person's name with it, whoever this height value belongs to. Let's say they have all different heights or whatever. Whatever. So similarly I'll have to create 4 variables for weight also, right? And then as you can see, I'm already starting to get an error for height, because there is no variable name height any longer in this. So if I have to calculate BMI for 4 people, I have to write this formula also 4 times with weight 1, height 1, weight 2, height 2, weight 3, height 3, and so on. So BMI 1, BMI 2, BMI 3 will be created. Then if I have to print it, I'll have to print 4 times also. So every line basically got quadrupled, got multiplied by 4. So is that how code should be written? Is that the right way in your view? If we write code in that way, do you think we'll be able to achieve a lot of things? No, right? Because if we are dealing with lot of variables in a particular scenario, what will happen is we will just be basically, keep writing lines over lines over lines, and keep creating thousands of variables. If I have to work with a data of 1,000 people, I'll probably create thousands of variables. So that is pretty much, you can say, nonsensical. So what do I basically need in this scenario? If you look at just one requirement, if you have to underline or find out one thing that we really need in this scenario to get it done, to get this job done, what would that be? Anyone? Gagan?
Inserting loops.
Huh?
Inserting loop.
So we need a way to run through all 4 variables one by
Yeah.
one.
Okay. Anyone else?
Take input from the user.
Basically, somehow we can take inputs, but we can't, like if we have to operate with thousands of values, we can't depend on user to provide 1,000 values in the input. Okay. The user will tell me, I'll do the calculation myself. Okay. I don't need Python if they will have to do input 1,000 values. So basically what we need here is, you actually raised a very good point. I'll talk about that also later. But what we actually need here is, somehow I should be able to use just one variable for a type of value. Like I have 2 types of value here, that is weight, and types it is not in the data type sense, but in the sense that the types in the real world. So here I have one type is weight, one type is height. So somehow I should be able to use just one variable but be able to store multiple values for that same type of data, right? So if I have 4 people's weight, then I should just be able to use the variable name weight, and it should basically represent 4 people's weight somehow. So 4 values of weight I should be able to store with a single variable name. I think something like that if I get, I will be able to resolve the problem. And the second step will obviously be that when I start doing the calculation, I should be able to access the individual weight of one person, like the first person's weight and the same first person's height, and use them in the formula and get the result for the first person. Then move on to the second person's weight, second person's height, and use that and print out the second person's BMI and move on to the third person's weight and height. So somehow I should be able to store multiple values with a single variable, and I should also be able to use these individual values when I need them, right? I think if we get that superpower, we can get this done, right?
Is this where the concept of arrays come in maybe?
Yeah, very similar thing. We are going to talk about lists. Okay, so lists is that thing that can help us out. Okay, Arrays we call it in different like in other languages we call it array, but here in Python also we have arrays, but that is a different topic. In a particular libraries scenario we call it array, that is a different thing. We call it lists in Python. Okay, so what is a list? So in the case of list, what happens is you basically have to put two square brackets, opening square bracket, closing square bracket, and between the opening and closing square bracket you can put your values in comma separated fashion. So if I have 4 values, I'll put a comma b comma c comma d, and if I put them in comma separated fashion within the square brackets, I can create something called a list, and I can assign that value to a single variable. The accessing part of the individual variables, we'll talk about that later. How can I access the A out of the list? We'll talk about that later. But for now, just focus on how we create a list and how we put values inside it in such a way that single variable can carry that complete set of values. Right? So now if you remember earlier we discussed this concept, right? Fundamental versus complex data types, right? So this is the first example of a complex data type. This is complex, right? Because in that single data type you are able to store individual values. These can be fundamental then. Okay, so basically I can have a list which can have numbers like 1, 2, 3, 4 inside it, for example. So 1, if I look just at 1, what is 1? What is the type of 1? It is integer, right? This is also integer. This is also integer. But collectively it becomes a list. If I check the type of this entire thing, Python interpreter will tell me that this is a list. But if I somehow access just the one out of this list and check its type, it will give me integer. Am I right?
Yep.
Pretty straightforward, nothing complex, right? So let's explore the lists further. So let me create one simple list for you. Okay, what I'll do, okay, let me create one more file. Let's just call it lists.ipynb. So one example list. Okay, it has like 4 float values. So if I just give that as an input, the same thing will be returned back to me as the output. No big deal. But the very next thing that I can do is I can say, for example, variable name is fam and it is equal to what? The whole list. Now if I run this, and if I print fam, prints the whole list. So I can represent these 4 different values with a single variable name. Okay, if I were to check the type of fam, it is a list. Clear? So what can lists do for us? So lists can do 3 things basically at a high level. You can name a collection of values with single variable like we did here. it can contain types like floats, booleans, integers, strings, okay, inside the list. Now in this case, when you see this list, it is all the values inside it are all same type, floats only, okay. But we can also have lists which can combine the different types of data together also, okay. We do not necessarily want them to be homogeneous. Homogeneous means that all the different elements that we have inside the list are all of the same type. We don't necessarily, it is like not mandatory. You can have different types of data together in the list also, okay. So one can be a float, another one can be integer, the third one can be string, the fourth one can be boolean. All of them can exist together in the same list also, okay. So let me show you one example of that kind of a list. So let me create another list, fam, same, the variable name is same, but here the first element is a string, second element is a float, then string, then float, string, then float, and so on, okay. So basically this is the name of the family member and their height, name of the family member and their height, and so on, okay. So if I print fam, just for the sake of it, it comes out as this. So generally when you give input with double quotes, while saving it in the background in the memory, it comes out with the single quote, so don't get confused. You could have put single quotes here also, but while saving it in the memory, it is always saved with single quotes. Fine, means the same thing, not a big deal, okay. So going by the same concept that a list can store other types of data inside it, and we also know that list is also a type of data, so why can't we have a list that can store other lists inside it? Why can't we have a list of lists? Right, we can do that one single list has other lists inside it. We can do that, right? Because if this is one type of data, then this data can also be part of itself, because it is a complex type of object. We can do that, okay. We can create a list of lists also. Clear? So let me show you one example. So we can also have a list of lists like this one. So in this case, this is different from this one, okay. It is different in the sense that this is the main list with the yellow brackets, and then inside that the element lists are the ones you see with the purple brackets, okay. Then further inside these lists you further have their own elements, which are strings and floats. So you see that one more comma is coming afterwards. There is a comma between these two elements, but then there is a comma after the element also. Is it clear?
Yes.
Any confused? So this is what you call a list of lists. Now I am using this term very vaguely, but let me make it more evident to you. These objects that you see inside a list, there is an official name for that. It is called element, okay. These are elements of the list. Okay, so if I use element word, don't get confused. Okay, so this is the element list, and this element list has further these two elements. Clear? Okay, so if it is clear, so with the knowledge that we have till now, let's do some problems. Okay, so what I want you to do, I've mentioned the steps. Okay, so just a minute. So let's say you're building a house. There are different types of areas within the house, like you have a hall, you have a kitchen, living room, bedroom, bathroom, so on. So 4 variables you have to create first. Okay, hall, kit, live, bed, bath. Okay, first you create these variables and you assign them with these particular values which represent the area in square meters for that particular part of the house. Then you create a list called areas and use the above variables to create that list. Okay, and then you print out the list areas that you created in this step. Okay, simple. So I am more interested in this code. Just do this in the interpreter and paste it in the chat 1-to-1. Okay, so a lot of you are done, so I'll start doing it now. So what you basically had to do is create these variables one by one, and then you had to create the areas list. Okay, all these variables you have to put one by one. And then you had to print the areas list. Okay, fine. So in the next problem, if anyone has not done this, then so in the next problem what you have to do is you have to modify it further. The same areas list that you created, just modify it a little bit and also add these strings which represent the respective areas in, like right before hall add hallway, right before kit add kitchen. In the same areas list, just modify it and then print it. Okay, these strings you have to add in the list. So this same list basically you had to modify. Okay, and the final list will look somewhat like this. So hallway, kitchen, all these strings you had to add in the respective places, and you had to print the areas, the new areas list. Simple task. In the next problem, you just have to choose the option, the correct option. Okay, so in this one what you have to do is you just have to tell me which of these are valid or which of these are correct. Do we have a list in these options A, B, C which is incorrect? So you have 4 possible answers, 1, 2, 3, 4. Just tell me based on your reading of the situation, 1, 2, 3, 4. You can just give me one option. Validity.
Looks like all of them are valid.
Yeah, whatever you feel, just put in the chat. Yeah, so the correct answer is the first one. All of them are valid. Most of you have answered it correct. This one is also valid, so this one will get multiplied, this will get added, and if you will try to print this string, it will print as 3 and then a string with 5 A's in it and then 3. So other than that, obviously these are very obvious correct options. So yeah, the first one is the answer. So in the fourth problem, basically I'll give you a list of lists, that is house. In the chat also I'm putting it. Obviously you will not be able to copy it, but you can create this yourself, and you know just basically create this list house, and print out the list house, and also print out the type of the list house. Okay, this is the problem. The same list, just modify it to be a list of lists, and the variable name will, instead of using areas, you can use house. And I want you to print out house, and I want you to print out the type of house. Print out the type of house. Okay. So if you are done, so I'll also do it. So sorry. So this is the list house. It can be in a single line also, by the way. Don't get confused here. So I could have just picked up this list and put the square brackets in the proper places. So this one will also become the same thing. Okay, so it can be in a single line also, not a big deal. Yeah, so this list house, you just had to first print the list itself house, and then you have to print out the type of house. Okay, so some people have just done type house. Instead you have to do the printout of type of house. So why I wanted you to intentionally do this is I wanted you to see that you can call one function inside another function also. So within the print functions inputs, I am calling the type function. So this function will get executed, and then the print function will execute on that output. Clear? The output might look a little bit different. So in the case of printout, it shows up like this. So don't get confused. Classes are just a way of constructing your object. So print function is able to access that in the background and then print it. So it's not a big deal. It is the same thing only. List. Clear? Any doubt?
Yes. No.
Okay.
So it says class. So what does? Sorry, maybe I missed it. What is
So
class?
class is I'll talk about this further, but it is a OOPS concept. Okay, object oriented programming concept, where if you can create your own objects also. Okay, which behave in a particular way as you want them to behave. So that behavior of a particular object is defined using a class in Python. Okay, that if it is a list, then how it will be constructed by the user. They will put square brackets, then between the elements they'll put commas, and this is how they can work with the list and so on. So these properties of a list are defined in a class. Okay, So that's a high level concept beyond the discussion that we are having. So it is just showing that inside thing, so don't get confused. Okay, fine. Let's talk about the next topic. Okay, we discussed how to create the list and things with it, but how do we access the components, or what we call the elements of a list individually? Okay, so to understand that, we have to understand first the concept of indexing. Okay, so in the case of lists, something matters a lot, and that is the index numbers. So basically you have two types of indexing methods. Okay, you have two types of indexing, that is zero based indexing and negative indexing. Okay, so what is zero based indexing and negative indexing? Let's take a look at this with an example list. Okay, so let me take a list. So here so here let me zoom in. So this is a list, right? We created this list earlier. So in this list, as per zero based indexing, we, as the name suggests, 0. Okay, we start from 0, but we start from the left hand side and go towards the right hand side. So in this direction we are moving, and we are starting from 0. Okay, zero based indexing. So the first element, listen to this statement very, very, very carefully. The first element is 0. The index number of first element is 0. You understood? Although I am calling it the first element, but its index number is 0. Okay, so if I have to access this element individually, if I have to access this particular element outside the list, I have to use the index number 0. Okay, so your index number start with 0 and start from the very beginning of the list and go towards the end of the list. Okay, so this type of indexing is called zero based indexing. Clear? Any doubts? Now let's talk about negative indexing. So in negative indexing, we start from RHS and go towards LHS, so in the reverse direction. So the last element has an index number of -1. Okay, second last element has an index number of -2. So it starts from -1, it is not starting from 0. Okay, it is starting from -1 and going from RHS to LHS. Okay, right hand side to left hand side. This is how you do negative indexing. Is it clear?
Yes.
Okay, pretty straightforward. So let's see how we can use this concept to access the individual elements out of a list. So the same list I will quickly construct it. Okay, so out of this list, let's say I want to access Emma out of the list. So what I'll do, I'll say fam, and let's say I'll use zero based indexing. So 0, 1, 2. Emma has an index number of 2, so I'll put fam2 in the square brackets right after the variable name for my list, and when I do that I am able to access Emma individually out of the list. Okay, to further verify that, if I want to check what is the type of fam2, it is telling me string. But if I just check the type of fam, it will be a list. Is it everyone getting along? Everyone understanding what happened here?
Yes.
Yeah.
Right? So in a similar way, if let's say I access fam7, what do I get? I'm getting 1.89, which is the last element. So in total we have 8 elements in this list, but the index number of these elements, since they are starting from 0, the last element is 7. So what happens, just out of curiosity, if I do fam8, I get an error that list index out of range. Okay, because the index numbers go maximum up to 7 in this list, so I get this error when I try to access the 8th indexed element. Okay, because there is none. Is it clear?
Yeah.
So in a similar way, if I say give me fam -1, I'll get 1.89. So I'll get the last element by doing -1. Clear? So if I do fam -7, what do I get? I get 1.73. And what do I get if I do -8? I'll get the first element of the list. Okay, what do I get if I do -9 here? Again, list index out of range. Okay, so this is what you call subsetting. Okay, the thing is called subsetting. You can access individual elements out of a list by using subsetting. Then what if I want to get a portion of my list as a new list? Okay, that is by doing a process called slicing. I can slice my list just like you slice a mango. Okay, any fruit or vegetable. In the same way we are going to slice the list. Okay, I am going to extract a portion or a piece of my original list and get it as a new list. Okay, so what I'll do, I'll just, for example, I'll take fam. Okay, so let's say I want to access 1.68 and mom. These two elements I want to access as a new list. Okay, so let's talk about this here first. So let me copy this in a separate example. This is my original list. I want to put one slice here, I want to put one slice here, and I want to get one list which has these two elements inside a new list. Okay, so let me show you. This is index number 0, this is 1, 2, 3, 4, 5, 6, 7. So if you notice, my first slice has to come before index number 3 and my second slice has to come after index number 4, or you can say before index number 5, right? So basically, to make that slice, the code that I will write is fam 3:5. What is 3 here? 3 is the starting index number and this is the ending index number for the slice. So the starting is included in the final slice. What is the final slice? This is the final result of the slice. So this, the starting index number 3 that I gave gets included. So 3 itself will get included, but whatever I am giving as the ending index number is excluded from the final slice. So when I say 5 itself, that is 1.71, will not be included. It will be excluded. So you have to be very aware of this, that the starting number is inclusive or included, the ending number is exclusive or excluded. So your slice, to get this final result, it has to be 3:5. Is it clear?
Yes.
Yes.
So just to show that to you very quickly, if I do fam 3:5, what I get is this. And if I were to check the type of this, it will be a list. In these cases, it will, like in this case, it will be a string, because it is talking about the individual element. But here I sliced my list into another list. Okay, I can even slice it in such a way. What happens if I do fam 3:4? I'll get just one element, 1.68. Okay, because fourth element is mom, fourth index number element is mom, and a slice will be placed right before mom. So 1.68 will be the only element that I get in the final list, but I am getting this as a list only. Okay, so whenever you are using this colon structure and you have a starting and an ending index number, it will give you a list. So if I check the type of this, it will be a list. Clear? It is not going to be float. You understood the difference between this syntax and this syntax? I think it should be abundantly clear by now. So it's already 9:11. I have some practice problems for this also, but it's already too late. So let's do them in the next class. So come revised, because you have to do the problems in the next one. So just revise it before coming to the next class. Okay. Clear?
Yeah, sure.
Yep.
Any doubts till now?
No.
Okay, let me stop the recording.